Hey, today we're going to be talking about parallel and perpendicular lines. Our objective is I can identify parallel and perpendicular lines in the real world. Parallel lines never intersect. They are equidistant. They have the same slope and they are in the same plane. So what I mean by never intersecting is if you take a look at this line right here and this line right here, you can see that they're never going to cross each other. And the reason that we know this is because they are equidistant. So the distance between the two lines will always be equal. So no matter where I measure this, if I measure the distance between the two lines, they're always going to be equal, that distance. So that's what equidistant means. They also have the same slope and they're in the same plane. So what I mean by that is if I were to draw two parallel lines, they would be in the same plane. Well, that's kind of ugly. Okay, so the way that we show a plane in geometry is we just draw a box and then we put the arrows saying that it extends out forever and ever in all the ways. And so two lines will always be on the same plane. Three lines may not be though. Okay, so how do I write that lines are parallel? Well, you can use arrows. So when I use arrows, I'm not talking about the arrows that go on the ends here to represent that they're lines. Because in the last vocab lesson, we talked about putting arrows on the ends that represents a line, points on the end represents a line segment, and then one point and one arrow represent a ray. So when we use arrows to represent they are parallel, we just put the arrow right there on the line. So I just put one arrow just to represent, because that's kind of like my first set of lines. But if I have a second set of lines that I'm showing that are parallel, then I would use two arrows. Well, sorry, my mouse got stuck here. Okay, I would use two arrows to show that they are parallel to each other. So if I were to draw a line way over here and I put two arrows on it, I know that this line is going to be parallel to those two lines. And the same thing with these orange lines. If I were to draw one of these lines all the way across the world and I put one arrow on it, then it's going to be parallel to these arrows here. Okay, so we also use symbols in a mathematical sentence. So the symbol for parallel, when I say AB is parallel to CD, what that means is if I were to have named this line AB by using 2 points on the line, and this one CD, then I could say that AB is parallel to CD. Okay, now also having the same slope. This goes back to our algebra days last year. Having the same slope just means if we have -3 as our slope, remember we've got -3, and we need to make it a fraction because we need two directions. We need our up and down on top and our sideways on the bottom. So because it's -3, that means we're going to go down 3, and +1 means we go right 1. So any pretty point or corner point on this line, we're going to go down 1, 2, 3, and right 1. 1, 2, 3, and right 1. You can see that they are going to be equidistant from each other and never cross because of that same slope. Okay, they're never going to get closer to each other. If they had a different slope, then this line would be getting closer and closer and closer together, or further and further and further away from each other, depending on where they're intersecting at. Okay, so I could make any line I wanted to parallel to this by using the equation y equals -3x, and I can either do plus or minus any number I can think of. I can say plus 1,000,000. I can say plus 12,000, plus anything, as long as that slope is -3. That is a parallel line to these up here. The slope has to be the same. That is the only requirement. Okay, so where would I see parallel lines in the real world? Well, train tracks, notice that they have to be equidistant from each other so that the wheels can ride on there and so that they don't want to cross, okay? You don't want your wheels coming together. These are parallel with each other, the little things here. The little boards that go across are going to be parallel to each other. It just helps with more support. On the road, look at the equidistant line here. That's kind of hard to do. So if you're working in construction and you're making roads or anything, you got to make sure that those lines are equidistant. Make sure that this is equidistant from that and they're kind of equal on both sides of the lanes, right? So most of you guys are starting to drive right now. In nature, trees are parallel most of the time. So we can see in the forest, buildings are going to be parallel to each other. When you're laying brick, it gives it a stronger structure whenever you lay them parallel like this. Okay, you don't want to have one going this way and one going that way. Now that herringbone design, that's beautiful. That's different. That does give it some support. But then you have like this side would be parallel to the other side and so on. The other thing is you've got parallel lines here. You wouldn't want your stair rail to not be parallel to what the angle of the stairs is, because then your arm would be going up and down and up and down and up and down. That would feel weird. And the same thing with your parallel lines. And notice that these are equidistant. Each stair is equidistant from this one to this one to this one. And that's because you don't want like stairs that have like a big step and then a little step and then a medium step and then a normal step. So it's really important to know parallel lines. So your turn. Pause the video and look around the room that you are in and try to spot some parallel lines. Okay, so perpendicular lines, they always intersect. They form right angles. They are a special intersection. They form 90-degree angles. It cannot be perpendicular if it does not form a 90-degree angle. They have opposite reciprocal slopes in their equations, and they are also in the same plane. So how do I write that the lines are perpendicular? With a right angle box. So it doesn't matter which angle you choose to put the right angle box in. I could put it in any one that I want, just as long as I put a right angle box. That means it's equal to 90 degrees. You could also put it around the whole thing. Okay, you can put 90-degree box all the way around the whole thing just to know that that whole intersection, 90, 90, 90, 90. Okay, that equals 360 all the way around. The math symbol is going to be an upside down T to represent that line AB is perpendicular to CD. And then using your equations, we've got -1/2 and +2. And what we're doing here is if we have a slope that's negative, that's going down and to the right, and we have to have the opposite going up and to the right. So one has to be negative, one has to be positive. And then their fractions have to be flipped over too. So if you notice here, this slope here goes down 1, that's the -1, and right 2, so for the +2. So -1/2 slope. This one is 2/1. Don't forget to give it that bottom number. So it's going to go up 2 and right 1. So now you can see that they are going to form 4 90-degree angles. Let me change that color. 4 90-degree angles. Okay, so where do I see perpendicular lines in the real world? Anywhere. Some traffic signs have perpendicular lines on them. You can see that this is pretty much perpendicular. This is your notebook paper. The corner of your notebook paper is another example. Your computer screen has perpendicular lines on it. Railroad crossing. These buildings are perpendicular with the ground. Let me get a different color. Perpendicular with the ground. You can see perpendicular. Cliffs out in nature have perpendicular lines. I know we use trees for parallel, but they're also perpendicular, unless they're on a mountain. I know my people out there that are like, well, sometimes they grow on a mountain and that's not perpendicular. Well, yeah, but if it's flat land, it's perpendicular to the ground. And then in architecture, we use perpendicular lines. So there's lots of places. These aren't just the only ones. So your turn. Go ahead and pause the video, look around the room that you're in, and try to spot some perpendicular lines. Okay, now that you've unpaused the video, I want to do a challenge. Okay, see how many parallel and perpendicular lines you can find in this photo. So pause the video and try to find some. Okay, a few that I did. This guy right here, he almost got a perpendicular line, but didn't quite make it. But lamp posts with the ground, that's a perpendicular line. The trees are parallel to each other and perpendicular with the ground. You have the crosswalk paint here, perpendicular lines. You have, parallel lines. These are perpendicular. So lots and lots, perpendicular right here, parallel, 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 lots and lots and lots of lines on here. So that's it. Y'all have a good rest of your day.